Let's quickly run through the 9 rules of SURD. The first rule, the second rule, the third rule, the fourth rule, the fifth rule, the sixth rule, the seventh rule, the eighth rule, and the ninth rule. And you have to note that SURD is an irrational number, and irrational numbers are numbers that can be expressed as a whole number or fraction, e.g. pi, root 2, root 3, root 5, etc. In this video, I'll be explaining 3 concepts of SURD, which include basic SURD, complex SURD, and perfect square. For you to simplify SURD with ease, you have to know that root 2 is a basic SURD, root 3 is also a basic SURD, but root 4 is a perfect square because it's equal to 2. Also, root 5 is a basic SURD, root 6 is a basic SURD, root 7 is a basic SURD, but root 8 is a complex SURD because it gives us 2 root 2, because 4 times 2 is 8, and root 9 is a perfect square and is equal to 3. Root 10 is a basic SURD, root 11 is a basic SURD, but root 12 is a complex SURD because 4 times 3 is 12 and square root of 4 is 2, so that will give us 2 root 3. Root 13 is a basic SURD, root 14 is also a basic SURD, root 15 is also a basic SURD, root 16 is a perfect square and is equal to 4. Root 17 is also a basic SURD. Root 18 is a complex SURD because it will give us 9 times 2, which is equal to 3 root 2. Root 19 is a basic SURD. Root 20 is also a basic SURD. Root 21 is a basic SURD. Root 22 is a basic SURD. Root 23 is a basic SURD, but root 24 is a complex SURD, and that will give us 4 times 6, which is equal to 2 root 6. Root 25 is a perfect square. Root 25 is equal to 5, and that is a perfect square. Other perfect squares include root 36, which is equal to 6, root 49, which is equal to 7, root 64, which is equal to 8, root 81, which is equal to 9, root 100, which is equal to 10. You can see the number from 2, 3, 4, 5, 6. All these are perfect square. Why these are basic SURD? These are complex SURD. So this is a way to explain basic SURD, complex SURD, and perfect square. All this you need when you are dealing with simplification of SURD.